Hello and welcome to Mostly Weather. In this episode we are discussing microclimates. Are they a thing? How big are they? Media myth or meteorological fact? I'm Jeff Norwood-Brown, and as ever I'm joined by the Mostly Weather podcast team. Keeper of historic weather treasures, archivist Catherine Ross. Hello.
Hello.
Broadcaster, forecaster and powerboat racer Penny Tranter.
Hello there, Jeff.
And operational meteorologist, amateur naturalist and aspiring psychologist Helen Roberts.
Hi, Jeff.
Hello. Now, according to my favourite guide, the Observer's Handbook, microclimates are not mentioned. I do have a copy which dates from 1969 though, and therefore begs the question, how long have we had them? Is it a genuine phrase? Is this something that the media refers to that doesn't actually exist? So do we know when the phrase was coined? No? Well, I have it on good authority that the term microclimate first appeared in the 50s by a chap called Thomas Bedford Franklin in his Climates in Miniature study. And then since then, it's been adopted by, the whole World Meteorological Organization, really. Do you know when we adopted microclimates as an official thing at the Met Office? I'm looking at a lot of blank faces here.
Not a clue.
I think it was around the 70s really when these sorts of terminology was taken on. There wasn't much study into them really, but they were sort of known about, as we'll get onto. But what about a definition? Do we know how big a microclimate can be?
That's a good question, Jeff. And I think the short answer is probably no, because I've been looking around at various definitions and they often seem to refer to a small scale area. But what we actually mean by that, I think, depends on the context, really. So in some ways, you could talk about a microclimate on a relatively large scale, even almost a continental scale in some respects. But more usually, we're probably thinking about of the order of parts of cities, parts of towns, and smaller, right down to the really tiny scale of individual back gardens. And anybody who has any green fingers at all will be well aware of their own microclimate in their own garden, I would imagine.
Yeah, it's interesting. It's like the term local, isn't it? You know, that gets used quite a lot and there's no strict definition for it. At what point does a microclimate become a climate?
It really, I mean, like I said, there is no strict definition, and there's a bit of a grey area between microclimates and just regional weather differences or regional climate differences. But it might be useful if we just have a think about some of the things that lead to different microclimates. So obviously there's location. If we're thinking about the UK, there's latitude and longitude. So it's probably no surprise to most people that generally the further north in the UK you are, generally the colder the climate will be, obviously again with regional differences. Then there's the altitude. So again, generally speaking, the higher up you are, the colder it tends to be. We've got distance from sea or even large bodies of water, because water has a high specific heat capacity. So it tends to hold heat well, but it also has a long lagging effect behind the annual and daily variability of temperature on land. So that's something to bear in mind when we're thinking about microclimates. Where you are in terms of whether you're urban or rural or somewhere in between, that can have a big impact, particularly on temperature, but also on precipitation as well, how much rainfall you're likely to receive. And then, right down to the tiny back garden scale. And we might come back to that later in the podcast, but there are some interesting reasons we might want to pick up on those very, very small scale microclimates.
So I tend to think of microclimates as an anomaly from the surrounding area. Penny, did you?
Yeah, I would agree with you, Jeff and Helen. I think a city or a small area is known to have its own microclimate when its climate differs from the surrounding area. So I think for me, that is the main kind of meaning or definition of microclimate. And as Helen has said, the reasons for a microclimate could be topographic and natural, like slopes or hills. As Helen has also said about water, whether it's a lake, whether it's a sea that cools the air, or it can also be man-made, like ground covered in concrete, like we see in large towns and cities. because, you know, those kind of materials absorb the sun's energy in a different way from the land, and also radiate heat back into the air, particularly at night. So yeah, I would say it's more about when the climate of a small area or a city differs from its surrounding area.
I remember always being disappointed, actually, when I grew up. I grew up on a place called the Wirral Peninsula, which is in Merseyside. And whenever there was a forecast of snow, if the snow was coming in from the southwest, we were sheltered by the Snowdonia Range. If it was coming in from the east, we were sheltered by the Pennines. If it was coming in from the north, the Lake District there. So it had to be specifically northeast, the origin of the snow showers for us to get. And I remember seeing the whole country would grind to a halt, except the Wirral, which would be fine. And so that's probably why I never owned a sledge.
There's a
Oh.
similar joke amongst forecasters in our headquarters in Exeter, actually, about what we refer to as the Exeter Shield. So yeah, similarly, whenever there's any exciting weather going on, it might be thunderstorms or snow, the Exeter Shield goes up. But thinking from a more scientific perspective, we do have two areas of high ground nearby. We've got Dartmoor and we've got Exmoor, and they do provide quite a lot of shelter. I used to actually commute regularly between Exeter and Plymouth, and even that relatively short distance of, what is it, around 40 miles or so, you could see noticeable changes in the weather and also actually the climate on a longer scale, with Plymouth being generally much wetter.
Because generally our weather comes in from the southwest, isn't it? And Plymouth is right at the southwest of the UK. So geography obviously plays a part in this. Catherine, did you want to talk about the Isle of Wight and its microclimates?
Yeah, we've talked about geography, but underpinning geography is geology. And you find that particularly on the Isle of Wight. So we've got kind of a nice chalk band running kind of down the south, down the middle, chalk and green sands. That's fairly strong rock, really. And then to the south of it in particular, also to the north, you've got clays. But I wanted to talk about the south of the Isle of Wight, where you've got sands and softer rocks. And they have basically just slipped away from part of the south coast of the Isle of Wight over time. They've created an area called the Undercliff. And the Undercliff's actually currently the largest urban landslide complex in Northern Europe. It's been slipping for thousands of years and it's still going. So there's basically kind of two very active areas of landslip, and bits of it fall away every year one way or another. And then in the middle, there's a more stable area, and that's where you find a place called Ventnor. And it's now well known for its botanical gardens. And the fact that you've got this sort of low-lying slumped land, nicely protected now by a nice chalk cliff behind it, means that actually Ventnor and the whole Undercliff has got a climate that's on average 5 degrees warmer than the UK mainland.
Really? Which way is this facing?
So it's all facing south.
All facing south.
Yeah, so the chalk cliffs protect it from all the northerlies, anything chilly, any frosts, anything like that. And it's nice and low lying, so it's got a degree of warming from the sea as well, and basically points straight south.
This is right at the bottom of the UK, isn't it? Out into the Channel.
Yeah, next stop France.
Yeah, the English Channel. And does the chalk help at all? Do you think it reflects the heat?
I suspect it helps a bit. Its main role is just in protecting the land beneath it from anything that comes remotely out of the north. The Botanical Gardens have plants from Australia and the Caribbean growing outside year round quite happily without needing any additional gardening support. But historically, there's another kind of interesting point there, which is sort of about microclimates and health. And that's what I really wanted to kind of mention, because the Botanical Gardens are on the site of what was the Royal National Hospital for Diseases of the Chest. And essentially, it was a hospital for patients with tuberculosis. So by the time we got to about the 60s, they were able to treat tuberculosis with antibiotics. But before then, there was no medical cure as such. The only thing you could do was basically give patients plenty of fresh air. And they realised that this, this undercliff area where it was warmer, much more sheltered environment, they could build a hospital, all the rooms facing south, all the windows open all the time, and the patients could benefit from fresh air kind of year round because it was just that bit warmer, so that little bit more pleasant for them.
That was the theory, wasn't it, at the time? That, I
Yeah.
mean, I can't remember the name of the author who went away to the Caribbean to basically live there because he had tuberculosis, as you say, and that was what his doctor recommended. But of course, if you can't afford to go and live in the Caribbean, then the Isle of Wight is even better, I would say.
The Isle of Wight, certainly a decent option. Yeah, and there was a 130-room hospital there from 1869 to 1964, and it was, well, as successful as you could be without, if you like, real medical treatment for something like that. But it was just kind of, a nice little example of how a microclimate actually can be used for its health benefits. And of course, until not long ago, we would have Met Office reports coming in from what we called the health resorts. That was places like Bournemouth, and Ventnor is still sending in observations out of interest. And a lot of them are the kind of place people went to take the sea air and go for a swim. And
I remember looking at the sunshine hours, and that was the sunshine hour reports used to come in, how long the sun had been shining in any particular resort, and you had to take them. You were offered. How can I put this delicately? There was a lot of competition for the various places to say they had the sunniest place in the country. So you
very
had to be.
definitely.
Yeah, you have to be very careful to get the correct data. Yeah,
Yes.
so I'm just thinking about, you referenced Botanical Gardens there, and this was a thing, wasn't it, in the 1700s, 1800s, that people became absolutely fanatical about collecting plants from all over the world. And I'm thinking of, there's again on the Wirral, there's a place called Nest Gardens that grew up and is now part of Liverpool University. And that was just because of one collector decided he wanted to go and collect plants. And because of the unique climate that the Wirral has, as I mentioned before, Nest Gardens is still thriving to this day. And nearer to Exeter as well, we have the Lost Gardens of Heligan.
Oh, I love
which
those.
I've never been actually, but I love the sound of it. I mean, I expect
The
there'd be
pineapple pit is great.
Is it? Right.
Yes.
I was expecting dinosaurs and things to be found there, but it is mainly plants. And this is on Cornwall again, which is a peninsula that sticks basically out into the Gulf Stream, which keeps the UK climate warmer than it should be at the latitude we are. And again, it's got the most outrageous plants for the UK climate. We've got, tropical ferns, and as you say, Catherine, pineapples. And I think this sort of links into what I was going to talk about, which is walled gardens and man-made microclimates. And so if you go to any of the stately homes or country houses around the UK, mainly owned by the National Trust, they quite often have a walled garden. And the point of the wall surrounding the garden is not just to protect it from, say, like bunny rabbits and things like that, but it actually alters the climatology of the garden itself, so that you've got the walls will protect it from strong winds, and also mitigate frost to some extent by absorbing heat during the day and then radiating that out, so it doesn't, especially up against the wall, it doesn't get quite as cold as the surrounding area. One of my favourite places is in Devon, and it's a walled garden at a house called Knight's Hayes. And the garden itself is built on quite a steep south-facing slope. It was there to provide food for Knight's Hayes itself. And it's incredible because it is built on a slope, but into the lowest wall, the wall at the bottom of the hill, if you like, they have frost gates. And the idea behind the frost gate is overnight the cold air would pool against the lower wall. And to stop a buildup of frost, they would open the gates at the bottom and let the cold air out. And it works very, very effectively. And apparently this happens in walled gardens all around the country where there's a slope. They can open the gate at the bottom and let the frost out. I mean, obviously keeping an eye out for rabbits coming in. But they realised that the properties of these walls that were being heated by the sun during the day and then radiating the heat back out overnight, they could actually influence that as well. So they started, I'm thinking that there's Croxteth Hall up in the northwest of England, actually has a walled garden, and the walls are hollow, because what they used to do is they would light fires and use the hollow in the wall as a flue to pump hot air around it to keep the walls warm and therefore protect the plants during the day. So that was used to be just fires. Then, of course, they introduced boilers and pipelines. And then, moving forward to a few years ago, an old clay pit again in Cornwall, they started building in 1998 a thing called the Eden Project, which is well, I can't really describe it as a massive walled garden, but it's two biodomes, essentially. One of them recreates the Mediterranean climate and can grow all sorts of Mediterranean plants in that, but they've also got a rainforest biome, and they can regulate the humidity and the temperature just by opening the windows at the top. It's absolutely fantastic. If you ever get a chance to go down there, if you haven't been already, it's fantastic.
Oh, I love the Eden product. Just when you were talking about the fires in the walls there, Jeff, you reminded me of, it might be slightly off topic, but I'm sure I remember my granddad talking about when I used to work at RAF St Morgan as a forecaster. And back in the Second World War, he said that when there was fog, which is not unusual at all at St Morgan, again, due to the microclimate and the direction it faces on the north coast there, that they would light big sort of beacons, big fire beacons along the runway to try and disperse the fog.
That's it. I mean, I worked at St Morgan as well. It can get to a situation where the fog comes up the cliff off the sea and then dissipates just at the end of the runway. So as the observer, you're constantly watching for this fog to come across the runway, and it never quite does it. So this is one of the problems with building airfields. They obviously need a very open, flat area of land to be built on. Normally, especially in World War II, a lot of them were just grass runways. If there was a chance there was going to be fog, big open patch of flat grassland would be very susceptible to a thing called radiation fog, where the heat from the land radiates back into the sky overnight, cools the air above the land, and can produce fog. This is a huge problem especially to returning aircraft who'd maybe been off to fight in Europe, and coming back they couldn't land. So they came up with a thing called FIDO, which was the Fog Investigation and Dispersal Operation, which is one of those acronyms you think they came up with the word first and then tried to crowbar the rest of it into it. And these were just essentially massive pipes that ran down each side of the runway, through which they sent thousands of gallons of fuel, which they then lit. And this would create a local climate of a little bit hotter air, which would disperse the fog. And they didn't do it on every runway, but they did it on enough so that if you were coming in from Europe, there was at least one diversion airport, and then they would just wait for the fog to go and you could return to your normal base. But they used to use apparently 60,000 gallons of fuel per hour just to try and disperse the fog. And apparently it was very effective. It would clear that particular runway, but you've got to remember that fog forms on tiny soot particles. So downwind of the fog, you've now introduced a load of particles from the burning fuel. So it was quite often happened that they would have pea supers just downwind from the local airfield. But the thing was, they got the planes back, and I mean, they wouldn't do it in when in peacetime, because it's just not effective.
Yeah, we've got some pictures actually of sort of FIDO in operation in the archive, in these great big burning lines of runways. But it was, as Jeff says, it was an awful lot of fuel, but it was also incredibly expensive, and the fuel was needed to kind of fuel the aeroplanes as well as to burn the runways. And so one of the reasons why they sort of phased it out or found other solutions during the course of the war, was it just used so much fuel. It wasn't really a viable option.
There's a particular video I saw on the internet, and it was, this is where we they were showing the pipelines and that, and said this is where because we need vast amounts of fuel, this is where we store it. And there was these huge tanks right next to the runway full of fuel, and you think, really? If you wanted to take out someone's airfield, that's what you'd aim for, wouldn't it? So yeah, I'm not sure how they managed to keep it quiet really from anyone wishing to attack us. But I mean, that brings me on to things like I was saying about the fuel giving out smoke particles and creating smog, which we've touched on in other episodes as well. And this, I don't know, that sort of leads into urban heat islands, Penny.
It's a well-known phenomenon, actually, for many large towns, cities, not only in the UK, but across the world. And it's not actually to do with anything natural. it's due to human activities. So, this is quite an interesting one when you consider climate change and how may the climates of large towns and cities continue to change as we go through the next decades. So what you find with the urban heat island effect, or UHI is its acronym, what it's fondly known as, the temperature difference is usually larger at night than during the day, and also it's most noticeable in summer and winter. But the biggest difference in terms of seasons is during the winter. So if I take the day versus night first, during the day you've got lots of buildings absorbing, lots of heat from the sun. But as the temperature rises from those buildings, then you see, air rising, and you start to see convective air currents developing. And so you're getting a mixing of the atmosphere. So that is, keeping temperatures similar or perhaps a little bit lower than surrounding rural areas. For example, Barcelona is just a smidge of a degree lower during the day, but at night it's nearly 3 degrees Celsius higher during the night. And the reason for that is that during the night, particularly when we have clear skies and light winds, and particularly under high pressure, and we may see an inversion forming, and an inversion is where the temperature increases with height rather than decreases with height. What happens is that all those buildings are still giving off heat through the night, and that heat gets trapped below the inversion. So consequently, you don't see the temperature at night falling as much as it would do in sort of surrounding rural areas. So
and this actually, Penny, goes back to Catherine's point earlier about how health can be impacted by weather, doesn't it? For example, I think there's some evidence to show that it's not necessarily the daytime maxima that can be particularly negative to people's health, although that can be, but it's when it's prolonged combined with temperatures not dropping at night. So there's no chance for the body to have that recovery during the nighttime period and cool down at all. So I think this is something that climate change is just going to exacerbate, and living in cities is going to become really potentially very uncomfortable for some during the summer months.
As you say, it's going to have a large impact on health. The number of tropical nights where temperatures don't fall below 20 Celsius is increasing in the UK and other parts of the world. But there's another point regarding health in large towns and cities, and that is poor air quality, because obviously you're seeing more pollutants put into the air across the urban environment, from vehicles and industry and transport infrastructure. And again, if they're getting caught under that inversion, then they're obviously going to have an impact on people's health, particularly those suffering from heart and lung conditions.
It's interesting we're sort of talking about the urban heat island, and Jeff, you were saying earlier that the term microclimate wasn't coined until the 50s, but it's certainly something that historically people were aware of and were understanding. And actually, the urban heat island was probably one of the first that was kind of identified scientifically. It was actually identified by Luke Howard. Now, he's better known to us as the man who named the clouds. So he named our cumulus and cirrus and cumulonimbus clouds. But he also he was a chemist living in London, and one of the things that he was interested in was temperature, and so he compared the temperatures between London and surrounding rural areas and noticed that it was particularly warmer at night. Now, he put it down to all the fires in everybody's homes, but actually his book Climate of London was published in 1833. So what you're really seeing there is the rise of industrialization and the start of people moving to cities, and cities actually growing into the kind of the huge urban spaces that we have today. So it goes back a long way, pretty much into industrialization.
It's interesting, isn't it, that a walled garden relies on that heating effect to be beneficial, and yet the same effect is quite detrimental in towns and cities.
Something we haven't talked about very much yet is winds. So we've talked about temperature a lot and a little bit about precipitation, but obviously winds can vary depending on microclimates. The sea breeze is an obvious one, and of course many of us will be familiar, even if we're not sure of the reason why, that often beaches will be a nice place to cool down on a very, very hot summer day. But also thinking even more locally than that, we're not potentially very far away from having things like drone deliveries. You could order your pizza and have it delivered by a drone, and they're going to be very responsive to wind speed and direction. So we're really going to have to understand the wind profile on those very, very small levels, which are impacted by all sorts of things, and not least going back to the urban effect with all these tall buildings around. They create their own types of turbulence and what we call eddies and vortices. So it's a really complex thing to even understand in terms of observations, let alone predicting it in terms of a forecast.
Yeah, I mean, Penny mentioned, the fact that they can create thermals, rising air currents. And of course, if you get a thermal, the air rises, but air has got to come in underneath to replace that. But you also have a funneling effect as well with a lot of cities. And especially in Liverpool, when I used to work in Liverpool, there was a couple of streets there on a windy day. I'm not joking. People were hanging onto lampposts because so down from, I think, Castle Street down towards the Liver buildings, you would start walking, and it's downhill towards the River Mersey, and if you started you would start walking, and then if you got into a bit of a trot, there was no coming back from it. You would just be blown down the street, and at the bottom is a set of traffic lights, and literally people in suits were just hanging onto the lampposts, just trying to protect themselves from the winds. It's incredible.
It's funny because I experienced that when I was in Liverpool, but I didn't know what was going on. So I now understand why I got blown down that street.
So the chap that was hanging sideways off a lamppost was probably me, Catherine, all those years
Could have
ago.
been, yes.
Yeah.
And of course, you've got, Chicago's famously known as the Windy City, another very notorious windy microclimate because of the grid system there, and the wind tunnels. So, it's definitely not just the UK.
And also, just looking at other cities around the world, Sydney in Australia, during the summer, there's a huge difference in temperature between the coastal area of the city and also the inland suburbs. So we can see in extreme occasions that the coastal part of the city could have a temperature, say, 24 Celsius or whatever. But in a suburb up to 19 miles inland, it could be as high as 36 Celsius. So you've got a 12 degrees difference there. And the main reason for that is that the sea breezes that blow in off the sea don't penetrate that far inland. So you can see that as well as there being a lot of temperature difference in a sort of short space of distance, you're also going to have a huge difference in the wind direction and also the wind speed, and also the comfortableness for people in Sydney.
So to bring this to a conclusion, then, we haven't really defined microclimates, have we? Other than they are an area smaller than a climate. There's no real sort of definition as yet, but maybe one will be coming very soon, because it feels like this is quite a new thing to explore. It hasn't been around that long scientifically. So yeah, maybe an actual definition will be coming along soon. But it is good to know that we have invented the word comfortableness on this podcast, thanks to Penny. So that's it for this Mostly Weather episode. Can I just thank my panellists, Helen Roberts.
Thank you.
Penny Tranter.
Thank you very much.
And Catherine Ross.
Thank you.
The Mostly Weather podcast is produced by Clare Nasir. Editor is Adrian Holloway, and I'm Jeff Norwood-Brown. Do join us again next time as we delve into the weird and wonderful world of the weather.